There's a movie called The Theory of Everything about Stephen Hawking's life, and that's been very popular. It'll get a lot of people thinking about this sort of subject. He was quoted as saying, since he was one of the consultants on this movie, that he would love to have a simple equation that would give him the grand unified theory. Would there ever be an equation such as this?
Well, I would say that there would be an understanding that would give him a single understanding, really, from which all the rest can be derived. Yes, that's possible, but that's not so much an equation. Equations and mathematics represent the logic of quantity. How do quantities relate? Every variable in mathematics stands for a quantity of some sort. And how do those quantities change, and how do those quantities relate to other quantities, and so on? The logic of those relationships among quantities is called mathematics. So mathematics is wonderful at telling us about the logic of quantity, how quantities relate, how much of this and how much of that, and if you take, these two things and, put them together, then how much do you have, and so on. Well, that's mathematics. But all things that are important aren't necessarily functions of quantity. So math isn't necessarily the logic that can describe everything that's important. Okay, now the one understanding that I was talking about, from which all the rest can be derived, is the understanding that our reality, at least it gets our local part. Our reality is just a small part of it. But the key for us being in this little reality is to come to the understanding that reality is information, that this physical reality is not fundamentally real. Reality is information. Then that logically begs the next step, which is if it's information, then that's a virtual reality. In other words, reality expressed as data. A reality expressed as data then has another logical step that says the computation of the reality, the computation of the data, cannot take place in the same reality frame as the one being modeled, okay, as the virtual reality. In other words, the server, if you will, that's creating the data can't be in the same reality as the virtual reality that the server is creating. A little example of that is I use the World of Warcraft a lot. A little example is that the server that creates World of Warcraft can't be part of the World of Warcraft model. It has to be outside of the world that's computed, as the World of Warcraft world. So the server has to be outside that world. And that then, well, let me just extrapolate that a little bit. That means that, well, never mind. Sorry, I'm doing a lot of stops and starts here, but I got different ways to do this, and I'd like it to make as much sense as possible. The next main logical step is that if there is this outside, this other reality frame in which our virtual reality is being computed, then what is that? And to realize that that is consciousness. Consciousness is the computer. Consciousness is the server. Okay, now once you have all of those things, we basically have started from us being a small fraction of something bigger, but we've logically worked our way from the concept that this is a virtual reality up to the point that we are now a small piece of something much bigger than us, and that big thing is called the larger consciousness system. It's a data information system, a digital data information system. So that then allows us to ask questions like, well, where did that come from? And why are we a piece of that? And how do we relate? And then all these other things have also logical explanations to them. So I'd say that from the point of view of inhabitants of PMR, which of course is where Stephen Hawking lives and his viewpoint that we're talking about, the key idea from a PMR resident's viewpoint that you need to understand all of this is just the idea that this is a virtual reality, that our reality is best described as data. It's a computed reality. And once you have that understanding, the rest of it just kind of unfolds as logical deduction. The thing that makes the most sense as you peel that back out. So that's the key idea. But now that's not an equation. That's an identity. That is that reality equals information. Well, I shouldn't say reality. Reality from the perspective of somebody in PMR. Our PMR reality, our physical universe, is best modeled by data, by information, and that's the key. Now, we're working up on that key in science. A lot of scientific experiments are pointing in that direction now. So that's the good news. We finally got to the point where science is realizing that that's actually the best way to describe most of the experiments that have taken place in the last 50, 100 years, is that our reality is computational. It's virtual. So we're on the first step of the bigger understanding. So I don't think that we're going to end up with a set of equations, you see, that's going to describe this larger reality. Now, he's maybe referring to the set of equations that would describe just physical reality, because in Hawking's limited viewpoint, reality is just physical. The physical universe is all there is. And then what he's looking for is the rule set. Okay, the rule set is that rule set by which our physical reality has evolved. And if he can write that rule set down, which now the rule set may be largely a function of quantity. It's about how things relate, how energy exchanges, under what conditions, and so on. So that's about quantity. And he indeed may find that the rule set describes all of what he thinks is reality, which is, of course, just this physical virtual reality. And it would be the same for the elf. If you're an elf inside of World of Warcraft, if you knew the rule set by which the World of Warcraft world was computed, then you'd know pretty much everything that could take place within the World of Warcraft, because you'd understand the rule set that generates it. So we have to start with the idea that Hawking's viewpoint is a very limited viewpoint. He's only talking about understanding this physical reality, which indeed is not physical, but a virtual reality, and then he's looking for the rule set. In a bigger picture, the rule set that derives this reality, that's just one small thing that's going on inside a larger consciousness system. That's just one piece of a much bigger puzzle. Because if you don't see that bigger piece of the puzzle, then you can't understand things that are outside of quantity, like things that are subjective. You can't understand things that sometimes violate the rule set, which can happen under certain circumstances that are defined by the psi uncertainty principle. And you can't understand things like, why are we here? What's the point of this virtual reality? Those sorts of things. To understand those big questions, you need a bigger viewpoint of the reality. So even if Hawking had a complete description of the rule set, he'd still only understand a tiny little thing about everything. The theory of everything has to take in more than just physical reality. That's just a little piece of everything. So to begin with, Hawking has a very small picture of what reality is, and his everything could be explained if he knew all of the rule set. And indeed, he may find some equations for that, but that's hardly everything. That's like the flea on the dog, that thinks the whole world is, composed out of this dog's hide, and doesn't really, he's born there, he's going to spend his life there, and as far as he's concerned, the back end of this dog is all there is to reality. Well, that's kind of the way we are, we see this virtual reality, and we think that really that's all there could possibly be to reality, and we're not aware of other things. But that means we'll never see, we'll never understand what derives bigger things, like, why are we here? Where did the dog come from? Where did the blood come from? What's going on here? What's the bigger picture that explains all this? Then you'll never see that. So he's really not looking for a picture of everything. He's really looking for a little picture of an explanation of the physical universe and the physical reality. And for that, yes, the rule set probably won't be an equation. It'll probably be a set of equations, but it'll probably be a small set, just like we do all of microscopic electrodynamics in a set of like 4 Maxwell equations takes care of it, and then there's a couple of other minor equations that do a few other things. But that's a huge field with lots and lots of logical consequences, and we wrap it up into just 4 basic equations. Well, we'll probably find that the rule set is not a large set of thousands of equations. It can all probably roll up in just a few. In fact, that's what Whitworth has done. That's what Brian Whitworth has done. He's come up with a way that has maybe, I don't know, I read it some time ago, but I think there was maybe 3 or 4 fundamental assumptions, things that he decides, which you could call equations. You could write those in the form of equations. And everything else that he does evolves from those several concepts. Okay, that like he defines something called a Planck process. Okay, that's one of his things that he defines. And if you read his work, you'll see it's just a few things that he states as kind of the fundamentals of his theory. From that, he derives, light and force and gravity and, everything else falls out of those few things. So we could look at Whitworth's model and say that, okay, Brian Whitworth has derived the rule set more or less in terms of a couple of simple mathematical ideas. So maybe that's the one Hawking's looking for. You see, he needs to go read Brian Whitworth's stuff and see if he agrees with that. Now, I don't know that Brian has covered everything, so I wouldn't say that he's, has a complete theory of physical matter, but he's covered a whole lot of it in just a couple of simple things. And it turns out they're not so much standard mathematical expressions as they are processes. You see, this is a process fractal, this reality. So Brian's, his Planck process can be mathematically described, but basically it's a process. And these other things that he talks about are processes, ways that digital things can interact with each other. So we've moved it from a strictly mathematical foundation to basically a computer science foundation, you see. So the mathematics becomes a subset inside the computer science. And there's where Hawking and the other physicists are. They're looking at a subset inside a superset of computer science to actually understand the rule set of our physical universe. So maybe that puts it in some perspective. So the problem is that most physicists aren't yet to a point of seeing a big enough picture that they even have a very good concept of what, quote, everything, unquote, is. And they're really looking at a mathematical subset inside of a, like I say, a computer science, inside of a process subset, a digital process. And that's what Brian brings to the table. Brian is a computer scientist, and he sees the computer processes that will develop all of the physical attributes that we know. So that's kind of the idea, but that's still just a small picture. However, that small picture, once you understand that reality is virtual, will logically lead you to these progressively bigger pictures and coming up with logical ways of explaining the next bigger thing and the next bigger thing until finally you've got the whole idea of how the whole ball of wax works. And one might ask, well, how do you know that's right? How do you know that once you kind of get this bigger picture that you've got the right bigger picture? Well, the short answer to that is you don't. It's just a model. It's not necessarily right in the sense that it's the absolute whole truth and nothing will ever change. It's that you come up with a logical model that explains the data. See, we've got all this data, and the data isn't all about quantity. Sometimes it's about How do precognitive dreams happen? Well, there's lots of times that people have had precognitive dreams. It's not like, well, that's never happened. Of course, that's happened. It's been recorded lots and lots of times, and other such things like that we know of. How can that happen? Well, that's data. Those are data points, and looking at our purpose here, what works and what doesn't work here, and where does that lead? And we look at all these processes, and we then come up with a model that fits the data. And if the model is logically consistent, then that's about the best that we can do. So you don't really know that the model is the right model. You just know that it's a model, and it's only as good as it fits the data and as it is logically consistent. You see, and where it doesn't fit the data, then it's missing something. And where it's not logically consistent, then there's an assumption or a leap of some sort that's kind of beyond logic, and that would be then a weakness too. One would need to try to make it logically consistent throughout. So that's kind of the nature of the big picture and how far we can go, and is it right or not? Well, that's the wrong question. The right question is it useful or not? Will this model help you understand? Does it help you live your life? Does it give you context in which to be? And if it's useful to you, then that's good. And if it's logical, that's good. And if it hits all the data points, then that's good. And that's about as good as it can get. Don't ask for anything more than that. If you want more than that, then you're looking for certainty. You see, you're looking for something to believe in. And if you're looking for something to believe in, and you're going down the wrong path, you need something that you can be skeptical about, and something that you can be open-minded about, and take what's valuable to you from it, and just let the rest go. So I probably overgone your point there, Donna. Sorry to run on.
No, not at all. In fact, I wanted to.
Yeah, go ahead.
I wanted to expand on that. Is part of the difficulty that physicists have nowadays the fact that they are just concentrating on physical matter reality? You have mentioned before that there are other physical matter realities. Now, some of these physical matter realities are just physical matter realities. Ours happens to be one that is connected with NPMR, which is a non-physical matter reality. It is both, which is probably the problem with trying to find a unified theory. Would you say that is part of the difficulty? Our reality is connected to other, and
yeah, all the realities, all the virtual realities are connected to other. You have to have, if you have a virtual reality, then you have to have another in which the virtual reality is created. So all virtual realities and all what we would call physical realities, other physical universes besides our physical universe, exist, and there's many of those, but they're all connected to other. They're all connected to a non-physical part. And yes, that's a key idea. You see, if you think that this physical reality is all there is, we just have this physical universe and nothing exists outside of this physical universe. Well, that's illogical. That doesn't make sense, because then that requires the physical universe to have a mystical, pop out of nothing source. It has to come from nothing, because the only thing that exists is the physical universe. There's nothing beyond that. Therefore, the physical universe had to self-create out of nothing, which is not a particularly logical or useful thing to say. So, but if you have that idea anyway, so let's say you only care about logic, that's too hard a question to answer, so you just pretend that question doesn't sit there, that illogical issue, then this belief that there isn't anything more than the physical universe shuts you off from a bigger understanding. That's part of the reason that we're having such a hard time with the physical universe being virtual, with the fact that our reality, our physical universe is a computed, it's information. The experiments tell us that, but physicists have a hard time, saying those words or admitting it, even though that's what the data says, just like they've now for almost 100 years been in denial about the double slit experiment, says that this is not an objective reality. I mean, that's what it says, and all the scientists at the time that they did those experiments knew that that's what it said, and that's what was written about it, and that was perfectly clear. But we've kind of stuck our head in the sand and decided that, well, it's not that the reality isn't virtual, it's just that we don't understand the experiment. You see, and we don't want to jump to any conclusions because we don't understand it, and guess what? Nobody will ever understand it. It's impossible. So let's forget about that and not think about it. Well, what that does, you see, when you have this, it must be objective, it must be physical, and that's all there is, that belief cuts you off from a bigger picture. It cuts you off from being able to see and see the logic of a larger structure, because you've already defined away in your belief there is no such larger structure. And now finally we're getting to the point where they are having to admit that our reality is virtual, but in the same breath that they'll say, yes, it seems like this reality is virtual, they will deny that a virtual reality cannot compute itself, which of course is logic at about a 6-year-old level of understanding. Virtual reality can't compute itself. It doesn't take a physics degree to get that. That's obvious, but they can't bring themselves to say that or even talk about it because it doesn't fit their belief that there's all there is. So that's the problem. See, that's why I call these beliefs belief traps. Once you have a belief like that, then you're stuck. You can't see a bigger picture because everything that is outside of your belief has to be ignored or denied or something else. So that's the problem, Donna. It's yes, because our reality is just virtual. It is tied to the larger consciousness system, which you were calling NPR, the non-physical reality, as opposed to the virtual physical reality that we call it. Because you have these connections, then these connections manifest themselves. These connections are, create things that are measurable and that people notice here. And well, what we have to do then is deny them. These things don't exist. Nobody's ever had a precognitive dream. Nobody's ever gone out of body. Nobody has ever accurately remote viewed a target. Nobody has ever heard in their mind the thoughts of another person, telepathy. No, the placebo effect is, well, let's talk about something else. You see, we just have to deny all the things that are there kind of in our face that conflict with the belief that this physical reality is all there is and everything is physical, because all these other things are clearly non-objective, non-physical, as is the results of the double slit experiment, as is entanglement. There's lots of things that just don't compute in an objective physical reality, and science right now seems to be pushed into realizing this is a virtual reality, but at the same time denying that really means what it means. You say that means that it has to be computed in other. That's you saw that, Donna. You and I both saw that panel with all the physicists in it, and the subject was virtual reality, and you had 6 physicists, mostly high-powered, big reputation, physicists from very well-known universities, and all of them agreed that it was a virtual reality. And when Fredkin, who was among them, brought up the point that, well, it's a virtual reality, it can't compute itself, all of them kind of, got the blank look in their eyes, started to, look at their feet and change the subject. And he said, well, what else? And they said, well, we don't really know, but, we're not going to go there. So it was just obvious. I mean, anybody that wants to see that, it's on YouTube, and Donna knows how to get in touch with it. She's seen it too. You can ask her. But anyway, that's what you have, a bunch of physicists sitting around and they're discussing virtual reality, and they also, yeah, it's virtual. We all know it's virtual. It's computed. That's what the data says. And then you take something that's trivially obvious and logical as a virtual reality cannot compute itself, and suddenly you only had one guy there who would admit that was a logical fact, and everybody else basically denied it, even though it's just, it's like it's as obvious as one and one together make two. It's just that simple. But you could see the denial going on amongst that group of physicists who all agree that reality is virtual. So that's the problem. Yes, we are connected to a larger reality. It does show in our physics experiments. It shows in our personal lives, in our interactions with other people. It just, it shows everywhere, and we deny it. You will find people in the science community who say nothing paranormal, that means outside of objective physical reality, has ever happened. And anybody who thinks that it has is hallucinating or been duped. And you will hear that sort of thing, which is patently ridiculous. There's tons and tons of research that have shown all sorts of things that cannot be explained with an objective causality, but it's all basically denied because it violates the core belief of science. So therefore, it can't exist. And everybody who thinks it does exist then must be mistaken, or must be duped, or must be a hustler trying to, lie, cheat, or steal somehow. So that's the problem with belief. It's a trap from which, the believer is limited to he's limited by the limitations of his belief, and he can't see beyond it. So that's a real big thing. You have Hawking's, and he wants a few equations for a theory of everything, but he has no idea what everything means. He wants equations that demonstrate relationships of quantity within an objective physical reality. Period. You see, and well, that's a rule set, but he's aiming low, not aiming high for that. And that will restrict what he'll ever be able to find, because he probably won't find his answers in that equation. He'll find those equations as a subset of a computer science problem, because that's the way virtual realities work. Virtual realities are computer science problems, not mathematical problems. Yes, the mathematics has to be inside to show how things relate, but the overall structure is a computer science issue. It's process, not quantity. That's the key. So mathematics doesn't really talk to process as much as it talks to quantity.
Tom, that's exactly what I was referring to with my question. And I do realize everything is connected here. Of course, we're connected to, and all of the other physical realities are connected to the larger consciousness system. I was just wondering if if our physical reality is different than some others, in that we do have more of a direct connection. Are there some that have rule sets that are more constricted, that are not, for instance, they don't have out-of-body experiences, they don't have psychic experiences? Are there realities such as that? Because this is how physicists are acting these days, that there is nothing else. I was wondering if there were physical matter realities that were actually more constrained like that.
Well, the range of virtual realities goes from very, very loosely constrained, and that's where we would probably talk to just, we would just say that it's two or more consciousness all just sharing data. The only constraints there are the constraints necessary to define the language, if you will, to define the protocols of the ability to communicate. So just because two consciousness can communicate with each other, there's some structure to define that communication. There's some structure so that they share metaphors and concepts and ideas and so on. Otherwise, if you didn't have that much structure, then they wouldn't even be able to communicate. So we have, now that would be a very lightly structured reality in which all we have is communication protocols. But then we have much tighter constrained realities, like our physical reality, that has a rule set that has evolved this what we call our physical universe. And there's a lot more rules there. You see, the rules in just defining language are just the rules of the language, the rules of syntax, the rules of definition, that kind of thing. So you have some rules there to define language, but it's a much, much greater set of rules that defines a reality like ours. And there are some that may have even a more, I shouldn't say aggressive, but maybe even a tighter rule set than ours that would define fewer degrees of freedom than we have. It's a matter of how much freedom do you have to create this? What's the size of your decision space? You could have a reality that was so buttoned down with so many rules that your decision space actually got smaller and smaller because so much of what was going on was defined or limited, and that's certainly a possibility. And I suspect there are those reality systems that are more constrained than ours. There are certainly those that are less constrained than ours, but of those that I would call physical, with kind of a quote marks around physical, constrained enough to be what we think of as being physical, most of them are kind of similar to ours. That's not too surprising, because here you have a set of experiments, if you will, that the larger consciousness system has been running for a very long time. These virtual realities are designed to facilitate the evolution of the larger conscious system, the evolution of consciousness. That's what they're designed to do. So as the larger conscious system evolved these various these various virtual realities for its own evolution, the ones that are productive tend to stay and grow, or you can copy. This is a digital thing. If you have something that's very productive, you can duplicate it and repopulate it 100 times, that sort of thing. It's digital. And the stuff that doesn't work very well, you don't have a lot of that. Maybe that still is in the margin somewhere, but basically it goes away. So eventually you kind of converge to a good solution or an optimal solution for the system. So that's why a system that's mature has already converged to kind of the best practices, if you will, or the most productive processes and systems that it's been able to evolve at the time. So that's why I think most of these physical-like realities that are constrained to that degree with fairly constraining rule sets, they're very similar, because I think that's what works. That's the solution that works best. So we're not really terribly unique in our virtual reality here. There are other virtual realities that are just different. I mean, you can have lots of different initial conditions, in a virtual reality, and different seeds and so on. You could even take a single virtual reality and say, oh, it worked really well, here for a while. Let's just take that and replant that someplace else. It's like taking a clipping off of a shrub, and putting it in the ground and growing a new plant, right? Well, in the digital world, that's a trivial thing to do. You can take something, duplicate it, and change a few of the things in it and start it over again. So my thought is that it would have been inefficient for all of these various realities to all be started independently of each other and all from scratch. My guess is, as things worked and worked well, they were duplicated, and some parallel processing was taking place, and now you had 2 or 3 or 10 or 100 things chugging away, all of them a little different because they maybe evolved a little different, but all with very similar rule sets, because that's the rule set that evolution brought to the top of the pile as being the most effective.
All right, Tom, thank you. Also, in reference to what you were mentioning, the YouTube video, it's called Rebooting the Cosmos. There were 6 world-class physicists there, and Jürgen Schmidhuber was one of them. I think he was one of the braver ones to speak up. He said that whatever it is that we'll find, whatever the answer is, it will be simple. Simple, such as in your statement that consciousness is the computer. So we'll go on to Oliver's question, which is now leading into the double slit experiment, which you were just speaking about. His title is Liberating Aspects of the Double Slit Experiment. In your recent workshop at the U.S. Space and Rocket Center, you explained how the experiments scientists do actually have a reality-creating element to them, as the larger consciousness system will use any data from previous experiments as a basis to which new experiments results have to be consistent. So by the design of a new experiment that explores a so far unknown aspect of reality, we actually create a new constraint. From that vantage point, a scientist should probably not just see himself as an explorer that unveils mysteries of the unknown, but that he might actually be looking into a future place by the constraints that the results of his experiments will bring into existence. So the first part of the question is, would you say that in this respect, the result of the double slit experiment is actually an anomaly to the creating more constraints pattern, because it did not increase future constraints, but rather opened up the new possibility of transcending materialism? And the second part of the question is, does the reason why the implications of the double slit experiment were not so far grasped also lie in its liberation potential, but that the human race is not yet ready for this kind of liberation?
Yes, good questions, Oliver. The first one, and I had a question in the last workshop, the one in Huntsville, that asked a question that also bore on this, and he said, well, if every time you learn something new, you set new constraints, then are you going to constrain yourself out of business? Are all these constraints eventually going to get you down to where there's no more wiggle room? You have all these constraints, and now you have very few choices, because the more constraints you add, then the less wiggle room there is for something else new to create. And yes, that is the case. We are creating constraints, though, at a particular level in the virtual reality we have here. So we create a constraint, and that's at the level at which we're making the measurement. Okay, but we're making measurements now at a level that has, I don't know how many, but many orders of magnitude before it gets to the resolution of the system, the smallest particles, the smallest pieces that we can do, which are like 1 pixel of our volume. And until we get down to the end of the resolution, there's lots of things yet that can happen. So the restrictions aren't that severe. Okay, now the double slit. Okay, it did create a constraint. Well, it did create a constraint in the fact that when you the experiment itself, I'm not so sure. I may change my mind. I think I just agree with you, Oliver. The more I think about it, I've never thought about this before. The more I think about it, I think you're right. It didn't really create a constraint because it wasn't showing something new. It didn't go out and say, all right, here's a new star system, or here's a new bacteria, or here's a new molecule or atom or elementary particle. It didn't find a new thing. It basically demonstrated the rule set. It had demonstrated how this reality works. So it just showed the nature of the reality. And you create another constraint when you find a new thing. Bring something new into the reality. This wasn't new in the way of a thing. This was new in the way of an understanding. This was conceptually new, that reality wasn't objective and physical, but obviously we don't have particles going through 2 slits at the same time. Even though physicists use that kind of language, that's silly. You don't have particles going through 2 different slits at the same time. What we have is a probability, and the probability is broad, from 0 to, or from plus infinity to minus infinity. So parts of that probability go through the slits at the time. Now that makes sense. So we got a new way of looking at reality, but we didn't actually discover a new thing. And it's discovering new things that create the constraints. So I would agree with you. It didn't really create a new constraint. It opened up the possibility of seeing, as you say, of transcending materialism, of seeing things in a different way. It showed us the way things work, not a new thing. And secondly, why is it that physicists deny the obvious there? I mean, they didn't in the beginning. In the beginning, that's why we have people like Planck making statements that if quantum mechanics, if this experiment, doesn't completely blow you away, then it's because you don't understand it. You see, we have those kinds of quotes going out. They knew that it completely tore up the idea of objective physical reality, because it said that it's probabilistic. It's not objective. Objective and probabilistic, are at odds with each other. And why did they then, after that, after realizing the truth, why did they then deny it? You're exactly right. They weren't ready yet. They were still so committed to their belief that they just couldn't go there yet. And I think that it's not just that the scientists were not ready, in kind of in the way of they weren't ready for that science, as it is they weren't ready to go back to what they considered to be the bad old days, what they considered to be, the nemesis of science, and that is admitting that this reality has components to it that are not objective and physical, that everything isn't what we can tie down, we can put it under a microscope and we can analyze everything. There is nothing that we can't see in a telescope or a microscope. Yes, there's some things we haven't gotten to yet, but in theory, everything is physical and everything is objective, and we can study everything, and it's all known. So this idea of there things mental, things in consciousness, things out there that aren't physical and objective is just scary to scientists. They don't know what to do with that concept because it lies outside of their purview. It's not what scientists do. Scientists work on objective physical things. That's their view anyway, because that's what they think exists. So it kind of falls outside of science, and I think that's what scared them more than any. And you're absolutely right. They just weren't ready to take that step into saying, well, other, that's interesting. Where is that going to lead? It's like other, we don't want to go there. We were there. That's back when people were being burned at the stake because they didn't agree with the powers to be. We've already been there and done that, and we don't want to go back. We like this thing that everything's tied to this objective physical thing, and all knowledge is knowable and that sort of thing. It's this non-physical probabilistic stuff just doesn't work for us. In fact, Bohr, at the time when these physicists were meeting at Copenhagen, he came up with an alternative that was probabilistic way of describing reality. And you had the materialists on one side that said it's particles. We got to stick with particles. And Bohr said, well, we could explain all of these things better with probability, that we don't have an objective physical reality. We have a probabilistic reality. And there was a choice. And overwhelmingly, the choice was we go with particles. We're going to explain everything with particles. But of course, then, in order to make these explanations real science, the particles had to be, well, not particles like we know particles. These are quantum particles. And what are quantum particles? They're probability distributions, you see. But we call them particles, and that makes us feel better. So we do everything with particles. And it's all, not so scary anymore, even if the particles are a little bit, odd. But that's the kind of stuff. It's just physics is odd, and that kind of stuff we'll never understand. So let's shut up and calculate. So that's kind of where we've gone. And no, they weren't ready. And scientists today now have the same problem. they're worried about this non-physical dimension gaining power once again, and then taking control of the definition of what's true, and what's not true. And they see that as a return to the bad old days, and they just don't want to go there. So it's not just that physicists are hard-headed and pig-headed and trapped in their belief. They also see the non-physical as a representation of the way life was, 1500s, the Dark Ages or whatever, where the non-physical was the definer of truth, right? The priests, those high priests, opposed to today's high priests of scientists, depended on the non-physical. And now we've changed high priests to those that are the high priests of science, and things are much kinder, much gentler, and not as more productive than they were in those days. So it's that kind of a thing as well. So they're still not ready. They don't realize that they have to take, in order to go forward here, they're going to have to open up the door to other. They're going to have to see the bigger picture, and no, that doesn't mean we'll have to revert to the bad old days when the priests decided what was real and wasn't, and burned people who didn't agree with them. We don't have to go back to that was excessive. We can admit that other exists and do that in a logical, scientific, and very functional way and move forward. But that fear keeps them from going there. But they have to do that. They're going to have to grow up and get over that issue and realize that other is actually part of the big picture. And we do need to have the courage to take that on and deal with it logically and scientifically, and not revert back to the bad old days when logic and science were bad words. So yes to both of yours. You hit both of those right. Hit them perfectly. And I hope the physicists do grow up and become willing to change and do see that we're going to have to move forward. But I'm afraid that if they don't, they're going to get run over in a stampede anyway, because eventually, once they admit it's a virtual reality, the rest of it's all just going to happen. And if they don't get on board with it, then they're going to miss an opportunity to guide it to something that is logical and that is rational and scientific, because they will be kind of left behind, still shouting, oh no, it's not like that, and in denial. If they stay in denial, they're going to lose their ability to affect the result. And we want this result to be, yes, indeed, there is other, but that's part of a rational, scientific, bigger picture of reality, not that, oh, there's other, oh, now, my God's bigger than your God, and we get back into the old ways of working out our fear and our ego through deities and that sort of thing. So science needs to grow up here and take part of this revolution, not just bury their heads and stay in denial. Otherwise, it's going to be a worse trip and a rockier road if they can't make that transition and realize that just because we're including other as part of our worldview doesn't mean we have to go back to the Dark Ages. We can do that within the context of science and logic and mathematics and make it valuable. We don't have to go backwards, but they need to get out of their denial, or we're having a hard time going forwards. So that's kind of the crossroads where we are now. It's hard to go forward, because we are trapped by our fear of going backward, so that we can't take the step to go forward.
All right, the next question is from Raj. Does space exist? His question states, this virtual reality being run on the screen of our consciousness produces a high-definition 3D illusion. To visualize the virtual reality model, we imagine infinitesimal 3D pixels arranged in a special grid with presumably an associated volume. Is this just a metaphorical tool to help us visualize? Is there in reality such a thing as space?
No, space is a created or a manufactured quantity. And I would ask you about the World of Warcraft. There's space in World of Warcraft, right? You go up mountains, across streams. I mean, the characters move around in space in the World of Warcraft. Is their space real? Our space is the same as their space. It's a computed space. It's a perceptual space. But the space in World of Warcraft is just numbers in a computer. In other words, space is data. It's just information. And it's computed. It's not a fundamental thing. So there is no such thing as fundamental space. Now that gives us a problem, because being creatures of this 3D physical reality we call our universe, it's hard for us to conceive of anything, any process or anything happening that doesn't require space for it to happen in. So it's difficult for us to say, oh, you have this larger consciousness system and it's the computer and it creates virtual realities and does all this, but there's no space. And we say, well, if there's no space and it does it all in a point, but that's just us trying to impose our kind of intuitive sense that to exist requires space. And it's just not the case. It doesn't. It does in our world. It does in the world of Warcraft. It does in the Sims. Sims characters go have inside and outside their houses, right? They go get in cars and drive off to work. And obviously there's space and volume there, but not really. The space and volume is just an illusion. It's just information. It's data. It's the way the numbers are run in the computer. So we create simulations of all sorts. You create simulations in your work. You design bridges, and I suspect that those bridges you design, you use computers to make those bridges before you ever drive a tractor trailer full of lead weights across it. You have computer simulations, and in those computer simulations, things can fall, things can move. That means there's space. Where'd that space come from? You made it up in your computer. It's the result of your equations. Your equations make numbers as if there were space. You see, that sort of thing. So space is the way the data is perceived gives us this illusion of space. So any computer creates any kind of simulation that moves, just a simulation of a rocket or simulation of a ball that's being thrown. Well, that's space. It's space because you have an x coordinate as a function of time. Well, that's space. So if you have a coordinate called x and that defines distance and it moves with time, that defines space and time. So distance, space, and time are all right there. They're parts of the equation. It's the way the math, the logic of quantity, creates space. Now, of those three, the distance, distance and space are of the same thing, right? Distance means space. But time is fundamental. Time is a fundamental thing. You have to have time. If you didn't have time, you couldn't have consciousness. You couldn't have anything. Time is a fundamental requirement. The reason time's a fundamental requirement is you can't have evolution without change. You can't have change with a before and an after state, right? Before the change and after the change. Otherwise, it's not change. If before and after are identical. So there can be no such thing as change without a before and after. You can't have a before and after without time. So for anything to progress, for anything to change, then time is required. Well, nothing could evolve. Nothing could be. You can't say, we talk about the primordial consciousness was just a simple thing that could differentiate state A from state B. It was in this state or it was in that state. Well, if you can go from one state to another, that's time. So in the very perception of change, you've created time. You haven't created necessarily regular time, tick tock, that's regular. That comes later when you invent clocks and things that can measure time in small increments, and now you have a way of uniform time. But before you have uniform time, you just have conceptual time, or if you say primordial time or non-uniform time. But time is a fundamental part of the of this. You can't really have, again, a choice. A choice requires time. If you have a free will choice, then you have to have time before the choice and after the choice, because the choice has to make a difference. If it makes a difference, it makes a change. If it makes a change, it has to have time. So time is a fundamental construct in this, and that was created the minute that this primordial thing that was to become our consciousness system was able to identify state A from state B, or a 1 from a 0. That the concept of time, we call it a concept. Time is not a clock, but time's a concept. And if you need time in order to define change. If nothing changes, then wherever you start, it stays that way forever. You see, there's no point in starting because you can't go anywhere. So there is nothing. You have the null set, and from a null set, you have to have time, or you'll never be anything more than a null set. Or if you don't have a null set, whatever it is you have just stays that way because there can be no change. So time is fundamental, but the rest of it, space, distance, those other things are just calculations. So if you figure if you have fundamental time, then space is easy to create, right? Because then that's just a point every delta t, it moves. Well, just the fact that it moves means you have a grid. Somehow you have a coordinate system, and that's just mathematical, right? You say here's 0, and we're going to create all of our equations are going to be at reference to the 0 point. So as soon as you create a reference system or an origin, then the rest of it, space, is created by things moving in time. And it's actually created by the reference system itself. Once you have an origin, if you have like 3-dimensional spaces, you say here's an origin and here's x, y, and z, there's space. See, that's all you need. So space is a result of mathematics, the logic of quantity. Okay, does that get to your question?
Okay. Raj's next question is, do our senses constrain us to this reality?
Yes, as long as you are working just through your senses, then what you sense here is going to be part of this physical reality. So in that sense of your question, do your senses constrain us here? If it's sense data, it's from the virtual reality. That's where the sense data comes from. On the other hand, all the data you get doesn't have to come through your senses. You have other data besides that, and that's from your consciousness. You see, you are in touch with other people on the net with your consciousness. You get that data, plus you can imagine, you can think, you can take all of the things that you have experienced and mash those together in creative ways and come up with new ideas. And all of that is not through sense data, but that's data that comes to you outside of your senses. That's data you get in consciousness. So as long as you are talking about sense data, you're talking about the virtual reality, our physical universe, because that you are an avatar. You're a digital avatar, just like the elf. And the sense data is the data that comes from your virtual reality. But what you do with your consciousness isn't limited by your sense data. So in a way, we're trapped by it as far as our senses go to be in the physical reality, but we can get outside of that. We're not limited by it. Sense data is just a subset.